Problem number 4.
A U.S. rural bank is studying the relationship between the mean account balance for individual accounts and the number of transactions per month. A sample of 8 accounts revealed in the table below.
First step is to identify the null and alternative hypotheses.
As you can see po in the given problem, the degree of relationship is not stated. So automatic po, the null hypothesis is R is equal to 0 and the alternative hypothesis is R is not equal to 0. For the statement form of null hypothesis, we have there is no significant relationship between the mean account balance for individual accounts and the number of transactions per month. While for the alternative, we have there is a significant relationship between the mean account balance for individual accounts and the number of transactions per month.
For step 2, for problems under person-R correlation, we have to identify the alpha level, the number of tailed tests, and the degrees of freedom. For the alpha level, as you can see, it is not stated in the given problem. So if the alpha level is not stated in the given problem, then automatically the alpha level for that given problem is 0.05. The number of tail tests will be determined with the basis of the mathematical symbol used in the alternative hypothesis. So in the alternative hypothesis, for this given word problem, the mathematical symbol used is not equal sign. So therefore, the number of tail tests for this problem is 2 tail tests. For the degrees of freedom, the formula is n minus 2. So n symbolizes or represents the number of paired data given in the problem or in the table.
If you can recall po, we have 8 pairs of data in this given problem. So substituting it in the given formula, we'll have 8 minus 2.
Simplifying, the value for degrees of freedom is 6. Step 3, identify the statistical test that you're going to use for this given word problem. For the statistical test, it is person-R correlation because as you can see po in the given word problem, we are looking for the relationship between the two given variables. If that is the case, we are looking for the relationship of two variables, then automatically the statistical test that we should use is person-R correlation. If you cannot follow po the instructions here and you cannot manipulate your own calculator, all you have to do po is send me a picture of your calculator and from there I will just guide you.
For the shortcut method for problem number 4, we have mode and then stat and then a plus bx. Tapos we press 27 equal sign 32 equal sign 50 equal sign 24 equal sign 53 equal sign 10 equal sign 16 equal sign and then 15 equal sign. Next, for the y values, we have 11 equal sign 2 equal sign 5 equal sign 9 equal sign 7 equal sign 2 equal sign 4 equal sign and then 10 equal sign. And then we press on and then we can now get the values for the summation. So shift, stat, sum. Let's get the summation of x first. Equal sign. This is the summation of x or value for the summation of x. Next, value for the summation of y. Shift, stat, sum, then 4 equal sign. This is the value for the summation of y. Next, summation of xy. Shift, stat, sum, summation of xy equal sign. And then for the value of x squared, we repeat the process, shift, stat, sum, and then x squared, and then equal sign. And then, last one for the value of summation of y squared, shift, stat, sum, and then 3, and then equal sign. So that's it po for the shortcut method.
Step 4 is the computation. Now that we know the values for the summation, we can now substitute those values in the given formula for us to get the R computed. So again, here's the formula for the R computed. Substituting the values, we will have 8 multiplied by 1432 minus the product of 227 and 50 all over the square root of the product of 8 multiplied by 8,219 minus 227 squared and 8 multiplied by 400 minus 50 squared. I discourage you po to directly solve this in your calculator because of the amount of numbers that we have, and I'm not really sure if your calculators can parang like you can input everything in your calculator. So I highly suggest you compute for the numerator first, and then you simplify the denominator, and then you divide the numerator by the denominator, and then that's the time you can compute for the R computed.
Solving for the R computed, let's solve for the numerator first. We have 8 open, 1432 close, minus open 227 close, open 50 close, equal sign. That's the value for your numerator. Next, for the denominator, square root, tapos open, tapos 8, open ulit, 8,219 close, minus open, tapos 227 close, squared, close, multiplied by open 8, open 400 close, minus open 50 close, squared, close, equal sign. This is the value for the denominator. Then solving for the R computed, we get the numerator in the denominator 106 all over 3,155.33. The value for your R computed is 0.03.
Step 5 is the decision rule. Decision rule for person R correlation is reject null hypotheses if the absolute value of the R computed is greater than or equal to the absolute value of your R tabular. Identifying the R tabular, just like what we did in the previous lessons, we have to go back to step 2 and recall the alpha level, the tail test, and the degrees of freedom. Locating the degrees of freedom in the first column, we have 6, and you have to draw an imaginary horizontal line passing through 6. Next is to locate the two-tailed test, which is in the second row, and then look for the level of significance equal to 0.05 and draw an imaginary vertical line passing through 0.05. And the intersection of those two imaginary lines will be the value for your R tabular. Substituting the R computed and R tabular, our decision rule is reject null hypotheses if the absolute value of 0.03 is greater than or equal to the absolute value of 0.7067. Step 6, identify if we have to reject the null hypothesis or we fail to reject the null hypothesis. To know whether to reject the null hypothesis or we fail to reject the null hypothesis, we go back to our decision rule and check if the mathematical statement is true. So we have 0.03 or the absolute value of 0.03 is greater than the absolute value of 0.7067. So extracting the absolute values, we'll have 0.03 is greater than or equal to 0.7067, which is false. So we failed to reject the null hypothesis. Next step and last step for this given problem is the conclusion. The decision is we failed to reject null, so the basis is for the conclusion is the null hypothesis. And therefore, the statement will be there is no significant relationship between the mean account balance for individual accounts and the number of transactions per month. So to verify this, let us get the degree of relationship for this given problem. Since R computed is 0.03, it will fall in the range of 0.00 to 0.30, and the interpretation is negligible correlation, which is correlated with the conclusion that we have that there is no significant relationship between the two given variables. The final conclusion is there is a negligible relationship between the mean account balance for individual accounts and the number of transactions per month.